Look at this. Class parent. Imagine this parent takes one argument called name. It takes two arguments. So I'm going to declare those arguments. There is a function called parent function, which is going to have a print of these two data. Okay, this will work as usual because it contains a constructor initialized on top with the two data, and there was a function which is going to take two of these data. As simple as that. Now I'm going to have another class called child. The name itself child. Okay, and this child actually inheriting the parent. So this is what single inheritance. Line number 13 is what we call it as single inheritance. Okay, so it is inheriting the parent class. Now this is having another function, and this takes only one data from the global initializer. Now the beauty is that the child function is actually inheriting the parent. Okay, and it has its own function which is trying to take one of the variable of the parent. To be precise, one of the variables that got initialized in your parent. That's the beauty. Now, what you're supposed to call, or for what data that you need to create a constructor, you need to create a constructor for your child. Okay, so look at this. Child object is equal to some reference. As we discussed in last class, it is some reference. And I'm trying to call this child function. And I know that I cannot call a child with empty. First, let us run this. Okay, so let me call this. Using your reference of child class, I'm trying to call the parent function. So to child function as well. So what I basically did was a parent class which contains a init and then a function and then a child class which is actually inheriting the parent, and it itself contains another function called child function which is also having one of the attributes from the top. Now what I'm going to do, I'm trying to call the child function which is having this reference. Using this reference, I'm trying to call both the function. Beauty is that we know that parent class as an initializer as a constructor which is supposed to pass two data. So what I have to do, I have to pass a two data here. So let me pass it like this: Dhoni, comma Jharkhand. Okay. So now when I run, look at it. Three datas got printed. If you want to check what is getting printed, you can even keep some identification of print statement. Look at this. That's it. So when you run, first three functions are from parent and the next two are from the child. This is straightforward. Okay. Now the beauty is that look at it. You are trying to pass the two data to the child. Much to the delight, there is no such constructor initialized or declared there in the child to initialize these two data. But it doesn't worry. If it is in other case, it would have thrown error saying that function takes only one argument, you're trying to pass three. That's the usual statement. Now it doesn't vary because If it is not available in the child, it will automatically go and see the parent because I have inherited. It sees the parent, and yes, a parent contains the two argument to be initialized, so it get initialized, and so that the data is now commonly dispersed throughout your child as well as parent. That's why the self-dot name is actually used by both parent as well as child function. This is a straightforward inheritance, single inheritance. Okay. Now, you might be wondering, so what happens if I take this init and if I keep it in child? Does it work? So in early case, what happened? You're trying to initialize the data on the parent and you're trying to use it in your child. Correct? You're wondering whether you can able to use it this way. Let me run this. Look at this. Still you can use it. So it doesn't matter where you initialize the data. As far as this constructor is concerned, you can either declare on the parent or you can declare on the child. Okay, it is not gonna matter a lot. I repeat, it is not gonna matter a lot. The thing is that you can share the data among the parent and child when you declare the constructor either in the parent or in the child. That's the straightforward point. Okay, so that is the case. So now, as far as you concern, what is the class that getting inherited? Parent class is inherited by the child, like line number 55. Okay, if you think that parent is a single class, it is not the case. I repeat, it is not a standalone class. This parent also actually inherits a certain thing called object. Okay, so in Python, every class is actually an inherited class. Every class, because if you have a single class, that also indirectly inherits something called object. That's what I mentioned at line number 46. So usually this will be hidden at the back of any code. So output gonna remain the same. Output is gonna remain the same. But the point is that you should understand. So every class in Python has an inheritance always, and that inheritance what we call it as object. Okay. So whatever we seen is that a single inheritance where the init will be there in the parent. Again, we see the same inheritance where the init is in child. Then the data is getting swapped. I mean, not swapped. The data is getting exchanged between parent and child, and it is working perfectly fine. So now, let me go to the another scenario. Let me demonstrate in a better way. Okay. So I do have something called class sports, which as usual, which is inheriting an object. Now it is having init initializer to take some data, say self.a comma name comma country. So what is the point here? My class constructor, my parent class constructor trying to take two data. Okay, let me initialize that. I'm done. So let me take some function. So I'm trying to use sports display. Okay. So what is here? I'm trying to print both self.name as well as self.country. So this is the normal class, whatever we see till now, correct? A class which contains an inner constructor of two data and I've initialized the data and the same data is utilized by the function called sports display. So now I'm going to create another class called cricket. which is actually inheriting the class called sports. Got it? I had a class called cricket, which is actually inheriting the class called sports. Now, this also has some data to be initialized. Say name, comma, country, comma, event, something like this. Okay. So what basically needed is that these two data, there are three data which my cricket class takes. So let me initialize this self dot event is equal to event. I'm initializing these two because I know that my name and this country data which I supposed to pass it to my parent is already initialized. So there is no need for me to initialize separately. So what I'm going to do, that's it. Let me create another function called cricket display, which is going to print event. That's it. As usual, I'm trying to create an object for the child. So using this object, I'm trying to call both the function. Let me better copy paste. Okay. And that's it. So when I run, look at this. Very obvious because I forgot to insert the data. So let me initialize the data. Dhoni something Jharkhand, comma, say T20. Now my child is getting printed. If you ask me how I'm saying, because it would have called this cricket display and it is printing self.event. Now the beauty is that the parent constructor is not at all getting initialized here. That is the biggest problem. The parent constructor is not getting initialized here. That is a problem. So because in this area, name, country, and event, I've just initialized the event. So event is working fine as expected when I call the cricket display. But when I call the sports display, the self.name and self.country is not getting initialized. The reason is that now these two init as a different set of a name, attribute, or say argument. So what happening is that whatever I supply to my child is not actually getting passed on to my parent. The data is not getting bypassed to this parent constructor. In the other way, what you can say is that the parent constructor is not getting initialized. Okay, that's the point here. Your parent class is not getting initialized. So what you can do is that you can achieve this. That means you can call this force display here from your child constructor. Look at this. What is the class name? Sports. Sports dot init. That means you're trying to initialize the sports class. See, this is similar to this one. So I'm trying to create a constructor through the child constructor. Sports is indicating to its parent. Sports dot init. Inside that self dot, what you have to supply? Just supply the data that needs to be supplied back. Name, comma, country. That's it. So now look at this. Now it is getting printed. So this is other way to achieve your inheritance. So why this is called? Why this has been used? Because I know that currently in my program, My child has one set of argument, whereas my parent has another set of argument. When I try to call the cricket class, the data of or the constructor of my cricket is getting initialized, but not my parent. The initializer, the init on my parent is not getting initialized. So what happened? Let me supply all the data back to the child. Okay. From there on, I'll be supplying the data back to my child using this method or mechanism. Okay. This is like inducing the constructor of the parent through the child. But what the beauty? You are using your child object only. You are not creating a separate object for the parent. That is what important. I repeat. You are calling with your child object itself. You are not creating a separate object reference for the parent. With the same reference, you are making that inheritance to happen. And this can also be a possible statement. Okay, right. So this is how you can achieve this kind of inheritance. When you want to activate your parent constructor through the child, and this is the way you can do it. And if you look at this, right, you're still using your same child object for the initialization, but just to induce the constructor of the parent explicitly through the child, this is how you can use it. But the beauty is that you're still not using a separate object. You're still using the same object to call the parent. But the problem is that here in your constructor, the data is not getting supplied back to the parent constructor. So you're trying to supply that by using that line number 87. Okay, the same inheritance can also be achieved using the super method. So the only thing that I'm going to do is that here super and I'm going to remove the self because super by default will contain one object reference. So what I'm going to do is that I'm going to supply the data back to the same, almost the same what we discussed earlier, and this is almost the same, but here I'm using super method. So when I run, one second, some control S, sorry, look at this. This is almost the same. The only difference is that instead of me using the parent name, I am trying to use the super. What is super? Super is a method which is actually pointing towards the parent class. The only difference is that where if I use the name itself, class name itself, I have to I have to mention that object reference here because I'm trying to, initialize the data from the child. So I have to use the self here itself. But now it is like I'm supplying the data back to the parent. This is similar like I'm creating another constructor. In earlier case, it was like I'm trying to substitute the data, but here like I'm trying to create a separate constructor here. So I just send a data so that it get initialized on your parent. Okay. So this is another method to achieve this inheritance. Okay. Then the absolute, of course, right. The super method which helping us, achieving this inheritance where I can call the parent constructor through the child, even though I'm not calling that object reference explicitly, whatever it is fine. So you can argue with me, sir, that I can do with the first method itself, right? I can directly call the parent name and I can use or I can supply the data back to the parent. What is the need to use the super method? So super method ironically used or predominantly used when you try to have more than one inheritance. Clear? Of course, you can use with a single inheritance also, but predominantly the super method are widely used in the multi-level or multiple inheritance. Okay, let me take you to the another example. Right, now look at this example. This is something that I copied from other source. If you look at this as a class called rectangle, which initially having a two data, a length and a width as a part of this constructor, and it has two functions, area and perimeter, and it is usual mathematical calculation, nothing to worry. Then I have another class, and that is actually inheriting the rectangle. and I have another class which is actually inheriting the square. Okay, each and every class is getting inherited. Okay, now the cube as a function called as surface area, and the volume as a function, I mean the cube has another function called volume. Now I'm trying to create a constructor, an object for my cube class as I did at line number 146. So I'm trying to supply a data 3. So what happens here? Here I don't have any init. So what happens when it doesn't have any init? It will go to the parent and see if there is any way that I can put init. Yes, you have a length, so it will put 3. Then I know that I have to supply some more data back to my parent called rectangle. So I'm using this super method as we discussed in the previous problem. So using this super method, I'm trying to substitute a data. The length, what is length? Length is neighborhood 3 which has been passed from cube. So 3 comma 3 will be substituted to the super method. So it will go to the top. So it will be like 3 comma 3. So length and width will be initialized. Now look at that. At line number 147, I'm trying to call a surface area. Okay. So when it reaches a surface area, look at that. It is trying to call the super method. Look at that. It is using super, and from super it is trying to call a area. What does it mean? The super means it is not indicating the immediate parent, it is indicating the main parent, the rectangle. That is the important point to be noted. Super doesn't indicate the immediate parent square. Actually, it is indicating to your the hierarchical, the base parent rectangle. So from there, it takes the area, and that area will be multiplied by the 6, and that is what the output will be getting. So I have to print it here. So to the rest of the thing. Okay, so this is how the another way you can exploit this super method. Okay, super method is basically to induce the constructor of the parent class, and this example is to tell you that super doesn't mean that it is indicating to the immediate parent. Actually, it indicates to the base parent. That is a super method. If you want, you can do this print and you can try check. There you see, it prints output. Output doesn't matter, but the scenario you should know it. So in the earlier case, what happened? I need to just pass a data. So what I did was from the constructor, from the object of that child, I'm just calling my child constructor. From the child constructor using a super method, I'm trying to pass a data back to the parent. So instead of me calling the parent explicitly, I'm just calling within the child class. Okay, this is again the same extension of the same example, but it is in a different way. So that is single inheritance. Right now I have another inheritance, and this inheritance I'm just trying to showcase you that it is directed to the parent, as simple as that. This is also another way, or another way you can use it. Okay, that's a super method. So it allows the method of a super class in your subclass. That's it. What is subclass? Cube and square is the subclass where it is trying to use a method of your the parent class called a rectangle in this example. Okay, this is what the actual super method usage. I hope everybody got the context.